Good morning, ladies and gentlemen, friends. I am Satish Deshmukh. I am having a long experience, more than 45 years in corporate and industrial sector. Today we are going to start a technical knowledge sharing series, session number 1. Today we are going to cover the subject of gas mixture composition. As you see that in various tenders received from customer, gas composition are given. Sometimes those are in different units. For example, oil content is given in ppm. Sometimes moisture is given in milligram per meter cube. Sometimes in, for example, H2S is given in ppm, like that. So in order to calculate the properties of the gas mixture totaling 100%, there are different ways how to calculate the properties of the gas mixture. But today we are going to cover in a short video how we can convert percentage into ppm and ppm into milligram per meter cube and all that. So as you know, 1% is equal to 1 upon 100. Then 1 ppm means parts per million, means million means 10 raised to 6. So 1 ppm is equal to 1 upon 10 raised to 6. From this we get 1 ppm is equal to 10 raised to minus 4. So the formula is A percentage is equal to A ppm divided by 10 raised to 4. Now we'll come to second. How to convert ppm into milligram per meter cube. ppm into milligram per meter cube. Suppose it is given in ppm, how to convert into milligram per meter cube. So milligram per normal meter cube is equal to 0.0446 into molecular weight of that gas into concentration in ppm. This is the formula to convert milligram ppm into milligram per normal meter cube. Now you see here this factor is there. It is very important. So there is a Avogadro's law that at NTP condition, all gases in the world at 1.033 kg per centimeter square absolute pressure and 0 degree centigrade, it occupies same volume. Surprisingly, and that volume is 22.414 liters. So this factor has come from that. It is very surprising, no? All the gases which are in this universe, in this at 1 mole of that gas at 1.033 kg pressure and 0 degree centigrade, it occupies same volume, that is 22.4. So I surprised how these laws of nature are controlled by the somebody. For example, Newton's gravitational force law. There also gravitational force is proportional to the product of masses of those bodies, and M1 in this force is proportional to mass of one body into mass of second body, and it is inversely proportional to distance between two bodies, that is d square. So I am surprised how these laws of nature are controlled, and these are anywhere you go you will find the same thing. This is the same, it is applicable for that gravitational force on moon as well as on earth. Now coming to our main subject again, that we have seen that how to convert milligrams and normal meter cube into concentration in ppm. And to illustrate this, we can take the example of ammonia. For example, ammonia has got suppose 100 ppm is given, 100 ppm is given for ammonia, and we have to convert what is the equivalent percentage and what is the equivalent milligram per nm cube. So you can say that percentage of ammonia in gas will be 100 divided by 10⁴. That means equal to 0.01 percentage. So we are easily converting this into percentage now. Now suppose ammonia, it is given that it is 100 ppm, then concentration of ammonia in gas mixture in milligram per normal meter cube will be 0.0446 into 100 into 17.03, because 100 is given as a concentration of ammonia in the ppm. So the result is coming 75.95 milligram per normal meter cube. You can see here that this factor depends on the universal gas constant, and universal gas constant is referred to NTP condition. There are two conditions. One is NTP condition, that is 1.033 kg per centimeter absolute at 0 degree centigrade. Second is STP condition, that means standard standard condition, that is 1.033 kg per centimeter square absolute and 15.6 degree centigrade. Different countries follow different standard. European countries also have got different temperature. So it is very important that these conversion factors depend on the universal gas constant. So we can see, so we generally forget and casually write milligram per meter cube, but the really it is a unit is milligram per nm cube. So we are getting 75.95 milligram per nm cube. And percentage also we have observed that it is a 0.01. So this is what I wanted to cover in this session, and various knowledge which is there in the website or books, those are sometimes from the website we see superficial information, ready-made formulae. But my intention is to go into the deep conceptually and to understand what is the concept behind the formula. We can very well use this formula, but how this has arrived, that is the intention of our this series. The inverse ratio of that 22.414, inverse ratio of 22.414, it gives this factor. In many other references, it is wrongly given as 0.00, 0.04. 0.0409. In some references it is given 0.0409. So you may get confusion. So whether to consider this factor or 0.0409. But I have stated this aspect that if you want milligram per nm cube, then this factor is to be considered, because that has come from Avogadro's law, gas law, of that any gas you take 1 mole, it will occupy the same volume at one condition, that is NTP condition. So thanks for your time. Thank you very much.